Hi there and welcome. Today we're taking a look at something really special. At least it is to me. For those of you that have followed this channel for a while, you will probably know that I develop telecommunications equipment for a living. So what I'm doing right now at work is develop radio communications equipment for the maritime industry. And basically that includes VHF radios, MFHF radios, including DSC, AIS, and new developments in NavDat and VDAS. So yeah, what I have here today is the grandfather of some of the equipment that I'm working on a regular basis. And yeah, it came in these two massive boxes, and I'm not going to open them on camera because it's just going to be a mess. I can see that it's been wrapped in bubble wrap and some of those potato chips thingies. And yeah, I'm just going to open them and then we will take a look at what is inside. Okay, so I got it out of the box, and here it is. And well, this is the monitor and the keyboard part of it. The actual machine is enormous and extremely heavy, and I put it on the floor down below here, and we'll take a look at that in a minute. But as you can see, this is some very old equipment. So the first thing that gives a clue to that this is not just a normal CPM machine is the black button up here with the text Telex on it. This machine is filthy dirty and it needs a good clean. But there's actually a little LED or something like that, a little light bulb in this button. So once you press the Telex button, this is like a shift character, basically, on a normal keyboard. And as you can see, there are some very interesting keys here that only belongs in the Telex world. Apart from the Telex button here, of course, there is the bell button down here. And when you press that, it will ring a bell in the remote end. Obviously, for shipping, this bell character, when being sent, will issue a bell command to the terminal on board the ship, and then the captain on the bridge will know that there's a message coming. So the bell button is very useful and special for Telex machines. Of course, Telex is not using the ASCII character set, it's using a kind of a bow dot 5-bit character set, and there's a shift character that shifts between characters and letters. But anyway, that would depend a lot on the software as well, how that is implemented, because on this keyboard there are special characters that are only on ASCII, and then of course it also have the characters that are in the bow dot character set. But anyway, you can see some special keys on the top here, something like show, traffic, return message, reply, end call, and the reset button. And then some special ones, who are you, which is not used on a normal keyboard anymore. And the here is button is also specific for the Telex alphabet. So yeah, quite interesting, just based on the keyboard. Now if we turn our attention to the monitor, we will see that this is basically just a small 12-inch monitor. Although it has the text up here saying this terminal must be logged off when unattended. This monitor is filthy dirty, just as the keyboard. And I think it's been sitting in a barn or something, in someone's shed, I don't know. But it really is dirty and we have to clean this up before we start looking to power it on. But anyway, the monitor has a lazy Susan underneath so it can rotate. It's not working too well, but believe me, there is. Now if we look at the back, there's a brightness control, there's video in and video out, which is quite interesting. So you can actually daisy chain the monitors. And I think in our industry, in the maritime industry, this is often used for training purposes. Anyway, apart from that, there is a monitor input, and that the signal that goes into this monitor comes from the main unit. And this includes keyboard signals and video and some other stuff. So it's not a VGA in or a CGA in or something like that. The last connector here is the actual keyboard. So the cable from the main machine comes into here, and then the keyboard signals will be coming out from here. So they will just be looped through inside. So hey, I'm down here on the floor next to the main machine. And as you can see, it's really huge. It's wide and it's deep and it's tall and it's really heavy. So we're going to take a look at it on the floor. The first thing, of course, you can see is apart from the size, is the big logo down here, and I think this is, as far as I know, this is British Telecoms. Used to look like this. Then we have two floppy drives for the CPM machine in here, and I don't have the floppy disks, so yeah, we're not going to power it up. But if you see how dirty it is, I don't think it's a good idea anyway, before it gets cleaned up internally. Down in the corner there's a little red reset button. I am not sure you can see it, or it's outside the screen area. But the thing that is really interesting to me is this panel here. Okay, so if we take a look at that, we will see that it's split into two, one side on the left and one side on the right. Yeah, I'm not sure this is a sticker or it's some kind of translucent material, because I think actually it's meant for some kind of a display so you can see what's going on. You can see the left side is line 1, the right side is line 2, and apart from that they're identical. You can see the Telex interface, whether it's transmitting or receiving. You can see whether the host is transmitting or receiving, and then you can see if there's a fault or the line is up and running. And of course the same thing on the left here. Okay, so this is the back, and I apologize for the bad lighting here. But if we take a look, first of all we see that it's manufactured by a company called Automation and Technical Services, Bracket Communications Limited, and it was located at Bridge Road, Haywoods Heath, Sussex, RH16 1UB. So this is a UK developed machine. And the type number is 7936. So this is probably machine number 36, made in 1979. But if we take a look at the back, we look at the connectors. We have, of course, this fancy space age font, which was all the rage back in 1979. But we have a CPM port, and I guess that is what is used when you run the pip command. That means you can transfer data, serial port wise, you can transfer data from this machine to another machine. Composite video out, this would go to a normal monitor. Then we have the monitor cable here, and that is included. That includes the video signal and the keyboard signal. Then we have another COM port, which is a Telex terminal, so that would be something like a typewriter, but probably using Baudot and not the RS-232 format, not ASCII either. Then there's a system printer, a message printer, and a CPM printer. And yeah, normally in Telex or these kind of a safety critical equipment like this is, you would have a message printer connected at all times. So that would be some kind of a dot matrix printer, and every time you receive a message or transmit one, it will print it out. So this is before databases and before massive storage, hard disk storage became commonplace. So you would just print it out, and then you would keep it for 5 years or something like that, and then you would throw away all the printouts later on. Of course, for Telex, for safety critical things, safety at sea, it is very important to be able to go back and see what is the history, who sent what message, who did what, in case a shipwreck or something like that happened. So as soon as there's loss of life or something critical like that, you would print out your every communications. On the left we have two phone lines. This is a British Telecoms standard. You see the plug here. Apparently only one is connected and it's hard coded. This is not a plug, this is just a hole apparently. And then we have the power supply down here. Okay, so we're in, and it's quite interesting, the design. The two floppy drives and the power supply is up here on top. And then there is a plug-in Telex modem, and it's just a standard Telex modem that can be that you can slide out. And you can see there are those LEDs here. They match with the LEDs on the front panel. So there's room for two, and this machine has just a single Telex modem. But this has been in a separate little plastic box, and I think we'll take a look at that later, because I think it's a standard box that they just included in a CPM machine. But apart from that, we have two or three really big main boards, and two minor boards here. And they are really well made. This is industrial grade. So they should be able to just slide out by pulling these two tabs here. And so should the other ones. And okay, one of them is coming out. And yeah, anyway, we will take them out and have a look. So give me a second, and I will try and pull them out without destroying anything. Okay, so if we look inside, there's basically just 4 big PCBs, and then they all fit in a rack mount system. And it's actually quite interesting because you can use it as a normal rack mount system, where you just mount it to a 19-inch rack. But you can also, as we saw here, put it upright and then just put some plastic panels on both sides like this one we have here, and then it will fit in an office environment. So if we look at the first board here, this is basically just a bare board made by ATE, and then they bought on top of that, they just bought a standard CPM machine and mounted it on top. So this board here by RAID Systems Limited is actually a CPM machine, and we'll take a look at that in a few minutes. But if we flip it over here, you can see that the floppy connector that is up here from the CPM machine just went down here. The signals just went down to the backplane down here, and the same for some of the other connectors. So this board itself is actually the CPM machine. We can see the Z80 CPU up here. We can see a massive amount of decoding and RAM here, and the EEPROM here for booting, of course. So this is quite standard CPM, CPU, memory management, the memory, and the ROM for the bootloader. Down here we have the disk controller, and this chip is a bit corroded. I can't see exactly what it is, but I think it's probably a WD something, because they more or less always are. Then we have a timer chip, and this is I think from Zilog as well. And then finally we have the video circuit, and there's a video controller from Motorola. This is the 46505, also called the 6845. So basically this is a very standard 80 by 25 characters monochrome video controller. And we can see some decoder logic, we can see 2 memory chips, and then we have some parallel to serial converter up here, and this is the video out connector on the left here. So yeah, this is a CPM machine for plug-in from RAID Systems, and ATS must have bought that. This module on top here, you can see there are room for 8 of these. These are serial port connectors, and I guess one board has 2 serial ports on it. At least that's what it looks like. And they have been used for the printer. There's 2 printers possible, as we saw on the back panel. This one here is a CPM printer, and this one here is the comms connector. Together with that, there are 2 serial port controller cards. And of course this is ridiculous, because today you'll just buy a Max 232 chip or something like that and you're done. But this one here is enormous. I mean, it's really huge. The chip is a MM5303, and there are 2 of them, and I think they must be the serial port chips. They're from National Semiconductors. Apart from that, they have a lot of logic. I've never seen this much logic done or used for serial port communications. It's really ridiculous. This board is labeled a dual V24-V11 board. If you see there. And that is V24 is the RS232, and V11 is the RS422. So there's really not much to this board except the enormous size of it. There are jumpers everywhere. There are some another jumpers here that you can set. This is for the COM port speed, and this one is set for 1200 bits per second. Again, these connectors here are missing. This is where you would put your DB25 connectors for serial port out. But I guess the serial port is going back through the backplane here, so they wouldn't need these connectors. And again, they wouldn't need these line drivers here that convert a 12 volt to plus minus 12 volt to 5 volt and maybe back again. So really ridiculously huge board for RS232, and there are 2 of them, totally identical, and they plug into the backplane. Both boards are from 1985, and if you look at the chips, they're also from 84, 85. So this machine is actually not as old as the design says. So yeah, quite weird design, I must say. And it gets actually even weirder, because